Welcome to the homework video solution series for ME2010. The first problem we will be doing is chapter 2, number 2. The question reads, if the magnitude of the resultant force is to be 500 newtons directed along the positive y-axis, determine the magnitude of the force F and its direction. So for a problem like this, what we have to do is figure out what forces we have, and it turns out from here we have two exact forces. One of the forces is along this direction at 700 newtons, and they tell us that this is actually 15 degrees from this angle, but we know that to actually be 180 degrees from the positive x-axis. So when we do 180 degrees plus 15 degrees, the actual angle that we get is 195 degrees. Similarly, we have another force, and I will put this in blue. This force is in the first quadrant with the value F and its own angle theta. And the question asks if the magnitude of the resultant force is 500 newtons directed along the positive y-axis. So the force of the resultant R is equal to 500 newtons, and this is along the positive y direction, which we call J. Determine the magnitude of the force F and its direction theta. So we know that these two forces, the 700 newtons and this F, they add up together and the resultant is 500 newtons in the J direction. So what we should do is we should find out what is the actual force value of this 700 newtons in its component form. Now this 700 newtons is actually the magnitude of the force, and let's call this force B just to give it a certain identity. And we could write this force vector as the magnitude of the force times whatever unit vector it contains. For an angle 15 like this, what we actually need is the angle made with the x-axis. So the unit vector will be cosine of 195 degrees plus sine of 195. And because 195 degrees is an angle in quadrant 3, we will find that cosine and sine of that will be a negative value. So for right now, I will write this as 700 times cosine of 195 degrees in the I direction plus sine of 195 degrees in the j direction. Follow with this unknown f, we will write this f as a vector is just equal to some unknown value times a unit vector, which is cosine of theta in the I plus sine of theta in the j. And all I know is when I add these two forces together, FB plus F, the resultant will be FR, which is given as 500 newtons in the j direction. So this will look like the following. 700 cosine of 195 I plus 700 sine of 195 degrees j plus unknown f cosine of theta plus f sine of theta. This will equal 500 newtons in the j direction. So let me actually put j here and I here. And because we have both x and y components, we can actually separate these into 700 cosine of 195 degrees I plus f cosine of theta I is equal to 0 because our answer does not contain any x component force. Similarly, we have 700 sine of 195 degrees in the j direction plus f sine theta of j is equal to 500 newtons. And now we have two equations that we need to solve for. So how could we go about this? Well, what you'll notice here is that we have a system of two equations with two unknowns. So here what we could do is, with the first equation, I could actually explicitly solve for f, which gives me negative 700 cosine of 195 degrees divided by cosine of theta. And if I do the same with the second equation, when I isolate f, I get 500 newtons minus 700 sine of 195 degrees, all divided by sine of theta. And we could set these two equations equal to each other and then explicitly solve for theta. So what would that look like? Well, if I set these forces equal to each other, I get negative 700 cosine of 195 degrees divided by cosine of theta is equal to 500 minus 700 sine of 195 degrees all over sine of theta. And if I have two fractions with an equal sign in between, then I am able to cross multiply, and I'll show that with a different color. So the denominator of the fraction on the right times the numerator of the first one, and then I will multiply the numerator of the second fraction on the right times the denominator of the fraction on the left. And with this result, I get the following. I have negative 700 cosine of 195 degrees times sine of theta is equal to, in parentheses, 500 minus 700 sine of 195 degrees times cosine theta. And what I could do is I could divide both sides by cosine of theta, and then I could divide both sides by this negative 700 cosine of 195 degrees, so that I essentially get tangent on the left-hand side. So when I do this, what will I get? I get sine of theta over cosine of theta, which is equal to tangent of theta, and this will equal 500 minus 700 sine of 195 degrees all over negative 700 cosine of 195. And to find theta, I will just take the inverse tangent of this monstrosity. So that results in the following. Theta will equal inverse tangent of 500 minus 700 sine of 195 degrees all over negative 700 cosine of 195. Be careful how you insert this into your calculator, and we will solve for theta, which is the direction theta they ask in the question. So once we have this theta, what we can do is then substitute this theta into either one of these equations that we have, and perhaps it might be easier just to solve it in here, and then solve for f, which will give you your answer. Thank you for watching.